Good morning, good afternoon, or good evening, whichever the case may be. We are talking about reflections. Mulan, reflections, reflections in the water. Another type of transformation is a reflection. A reflection is a flip across a line. The line is called the line of reflection. The result is a mirror image of the original figure. To be a reflection, two figures must meet three requirements. The original figure and the image must be congruent. So that's the same as it was for the slide, the translation. Corresponding points must be the same distance from the line of reflection. So hopefully we can all agree that the two Simbas are the same size and shape, so they are congruent. But then the next one is whether or not they are the same distance from the center line, that line of reflection. So I might do something like this where I measure like from the tip of the ear to the tip of the ear. And this one's about 1.2 or 1.25. And then if I slide this just to make sure, this one is also 1.2 or 1.25. So we could say like 1.2 centimeters, 1.2 centimeters. So they are the same distance from that center line of reflection. And it says lines connecting corresponding points must intersect the line of reflection at a right angle. So when I connect the tip of the ear to the tip of the ear, this line that I drew makes a right angle with that center line. If I go from, let's say, the tip of the tail to the tip of the tail, we're also looking at about the same, like a 0.2 centimeters on either side. When I connect them, they make a right angle with that line of reflection. So at the bottom of the page, you'll notice there are some ones here that are examples saying, is it a reflection? Explain why or why not. So the two lightning bolts, they appear to be the same size and same shape. One has been flipped over. So up here, you can see like this Simba is looking to the right and this Simba is looking to the left because they were flipped over the line of reflection. The same idea here, the tip of the lightning pointing to the right, the tip of the lightning pointing to the left. However, if I go to connect the matching tips, you can see, oh, good, they make a 90-degree angle, so that's great. We get our 90-degree angle, but what we don't get is an equal distance from the line of reflection. This one's about 1 centimeter. This one's about 1/10 of a centimeter. So they are not a reflection because they are not the same distance from that line. We've got this one here where it looks like the two quadrilaterals are the same size and same shape. It looks like it's been flipped over. It is isosceles, so this one on the left going to look the same as the one on the right. But when I go to connect corresponding points, you're going to find that they do not make a right angle. Like this angle here is not a right angle. So that is also not a reflection. If you look at it, you can clearly tell that one is lower than the other. Now here we've got this sort of rainbow elbow macaroni look. They look like they are congruent, same size, same shape. They are also about the same. Let's see, this is about 6/10 and about 6/10. So they are about the same distance from the line of reflection. And when I connect them, they make a right angle. So that one is a yes. And last but not least, the two arrows. This one I think is the easiest to say no right away. The arrow on the left, considerably smaller than the angle on the right. So no, because they are not the same size. So here, different distances from the line of reflection, not Lord of the Rings. This one, not a 90-degree angle. And this one, we would say not the same size. You could also say not congruent. So when we take a look at the back, we're going to be looking at two quadrilaterals. We have one that is above the line of reflection, one that is below the line of reflection. So if we were to look for what is the line of reflection, we would need a line that splits those two and needs to be an equal distance above and below. So if I go right here, I would have a line of reflection that is on the x-axis because our image and our original are both one square or one unit away from that line of reflection. So which axis is it reflected across? It is reflected across the x-axis. It is a horizontal line of reflection. And I've got all my coordinates written out. You can see I've got the original coordinates, which is this one up here. This one's your original. This one's your image. I can tell because the original coordinates, L, M, and O, do not have that little tick mark in the upper right-hand corner called the prime. And the image do have the little tick mark in the upper corner for the prime. So original coordinates, L, M, and O, image L prime, M prime, N prime, O prime takes a lot longer to say. What do you notice about the coordinates? So the -7 stayed a -7. The 0 stayed a 0. My x coordinate stayed the same. But the y coordinate 5 became -5. The y coordinate 1 became -1. The y coordinate changes from a positive to a negative because it's flipping from above the x-axis to below the x-axis. That's a change in height. The height is changing. So I would say, I want to grab a neutral color here. The 5 became a -5. The 1s became -1s. So we would say the y coordinates changed sign by flipping over the x-axis. It is a height change, so it is happening to the y coordinate. The second shape that is there is also quadrilateral. The coordinates spell math because we're cool like that. The original coordinates, M-A-T-H, are over here. That's my original. The M prime, A prime, T prime, H prime, the image on the right. So it went from being on the left to being on the right. It flipped over this time the y-axis. And I know that because I've got A 2 squares to the left and A prime is 2 squares to the right. So that makes, in this case, the y-axis our line of reflection. And you will notice when it flipped over the y, the x coordinates were the ones that changed because my left became right, which is a movement on the x-axis. So for this one, we could say the x coordinate changes. Sign by flipping over the y-axis. All right, so at the bottom it says for reflections on the coordinate plane, if you are going to reflect over the x-axis, you will notice it is the y coordinate that changes from a y to a -y, changes sign. And if you are going to flip over the y-axis, writing in highlighter, always interesting, flipping over the y-axis, it is the x coordinate that changes. So the coordinates of a point and its image are given is the reflection across the x or y axis. The -4 becomes a 4, which is the x coordinate. If the x coordinate changes, it is flipping over the y axis as the line of reflection. And if the -3 stays a -3 and the y coordinate changes from a -4 to a 4, this one is flipping over the x axis as the line of reflection because the y coordinate changed.